Hello YouTube, RJ. Hey, today we've got we're working on that voltage calibrator, and so you may remember I purchased this little cheap pit controller to control the heater element in the little metal oven. So I'd have a temperature controlled oven for our voltage reference and A to Ds and everything. And I decided not to use this. It was just a little klutzy to try to get in. It was going to be klutzy. I got to thinking about it. I've got a microcontroller over here on the control board that's really got an easy life. It wasn't having to work too hard, and I got to looking, and there was some good libraries out there for PID control of temperature and such for the Arduino. So I found one. I took a look at it. I had to adapt it. It was designed to only be a PID. It used a delayed loop to make sure it always processed at the same time, and it has to process, whether it's half a second, 1 second, it has to process every time at a very accurate time to work well. Problem is I have other code that has to be processed. I have to run the screen, tell the screen what to be doing, take input, send information over to the A to D board, or D to A board, I mean. So that wasn't going to work that way. So what it is, I took the code and I tweaked and modified it. I created an interrupt version of it where it triggers every second on an interrupt to always process the PID every second, no matter what else is going on. And I found that I could do that and handle everything else without any issues. So because of that, I've built it up. I've got it to work. And what the big change that I'm doing right now is a couple things. Is one, I was using a MOSFET, logic level MOSFET that the Arduino was triggering to turn on the 24 volts to the heater element. I found these little, on AliExpress, these little solid state relays. Let me see if I can get you a good shot of them, maybe. They're SSR-41 FDD solid state relays. They're good for 6 amps at 60 volts. So up to 6 amps, up to 60 volt DC output. The trigger input is 3 volts to 32 volts DC. Current is very low, so I wanted to try them out. So I swapped out my transistor setup over here on the board, and I got one of these plugged in, got it all hooked up. It's working great. I run a 180 ohm resistor in series with the trigger voltage, and that keeps the current under control. Works great, no problems there. I'm going to give you a quick little demo of that, and then I'm going to show you, we're going to do another demo. Let me explain. The first demo is just showing it heating up and getting stabilized. What I'm going to do is I've got it set to warm up this oven to around 45 degrees C and hold it very stable. That's not real hot, but it's hot enough that it's going to be higher than any ambient in any lab or anywhere you would be working. So it's going to, we'll get a nice stable temperature. The reason I don't go warmer than that is because of the power usage. Since this is going to be run on a battery to keep the noise down when you're actually taking your readings, I want to make sure that the battery is going to last a very, very long time. So I don't want to bring this up way hotter than it needs to be, use a lot of excess power. We're trying out the new relay today is one thing we're doing, but we've got a safety issue that I want to talk about. So the first demo is just it coming up to temperature. And let me tell you a little what's going on, and then we'll talk about the safety issue. I've got a thermocoupler taped onto a board on foam, isolated from the walls, sitting in the middle of the air out here to see how long the PCB takes and watch it warm up. That's being monitored over here by my 7510 Keithley. And we're going to use that to monitor what the PCB board inside is doing. What I found was the best way to get a nice stable temperature on this was to monitor the temperature of the aluminum case itself, bring it up to the temperature you want, and then allow the board to heat soak slowly up to that temperature and stabilize. If I try to monitor it from the board, because there's such a thermal lag, it will get this case unbelievably hot, and then the board finally gets to the temperature, we massively overshoot, and then we go in these wild swings. This kind of gives you a little bit of thermal buffer. It brings the case up to the temperature and holds it there, so the air inside comes up to that temperature, and the board therefore comes up to that temperature, and kind of just keeps the environment at a nice even temperature. That works very well. So we're monitoring the board temperature on the Keithley, and the Arduino is monitoring its actual control loop feedback temperature from the case. This little temperature sensor right here is taped up to the case. I'm going to come up with some better ways to attach things. Then we have the top, and there's something on here. We're going to talk a little about this. I had a safety concern, and that is, imagine the solid state relay fails shorted. Imagine my code messes up and does something stupid. Imagine my temperature sensor fails and continues to tell the Arduino that it's cold. Imagine the Arduino locks up or my code does something crazy. If you were to turn this heating element that's mounted to the bottom of this case on at 24 volts and left it, it wouldn't be too long before you'd have a fire hazard. So I don't like that idea of just having, those possible dangers. So what I did is I found some thermal fuses off of AliExpress. These particular ones are rated for 10 amps up to 250 volts, and they're set for 65C, and they are fuses. They're not temperature switches. They don't turn on and off. They don't turn off when it gets hot, turn back on when it cools down. These blow and you're done. So the idea is at 65C, the top of this oven should never get to 65C. If it does, we know there's a problem because our PID controller should be controlling it and keeping it well below that. So what I've done is, for a test, I have Kapton taped one of them onto the top of this case, and I'm feeding the power for the heating element through this. And so when we're done getting this thing up to temperature and we're happy and it looks, things look good, you get an idea to see how it works. What I'm going to do is I'm going to come over here and I'm going to take the control of the SSR and I'm going to hard lock it on. And we're going to let this oven go wild. And we're going to sit back and watch and see how hot everything gets, and make sure the fuse blows, make sure that it fails safe, and we're good. So that's the second part of the test. And so I don't know what's going to happen. Might get so hot it starts melting the foam and smoke and catch fire, or might blow well before we're ready. I don't know. We're going to find out. So that's kind of the goal of today. Of course, we've got our insulation here to insulate the oven, keep it nice and warm. And I'm going to use my iron cleaner for a little weight to hold that foam down good. Normally the case bolts together and squeezes the foam tight. So right now we're pretty well ready to go. What I'm going to do is I'm going to get everything set up over on the computer. The program monitors the oven's temperature, the metal oven itself's temperature, and shows that. My Keithley over here is going to show us what the PCB board temperature is inside there. Give me a minute to set up. I'm going to time lapse through it. You won't have to wait the whole 15-20 minutes till it stabilizes. You're going to get to see how it ramps up, stabilizes. It will take 15-20 minutes probably to stabilize, but understand this thing, once it's up and going, that oven will stay up to temperature continuously. It'll be ready at all times. So let me get set up. We're going to get this going. Next thing you're going to see is a time lapse. Hey, I'm back. It looks like it pretty much stabilized out and is doing okay. And so now what I want to do is I want to see if my fuse is going to work. It looks like it's got the oven up to 45. Looks like the board's running about 36.7. So I might want to adjust that oven up a little higher and get the board a little warmer than that. I mean, that's probably quite fine, but I'll have to think about that, decide what I want to do. But I got a nice, fairly stable temperature, as you can see. So now what I want to do is I'm going to take, and the plan is I'm going to jumper the relay on full time. So this thing's going to go to full current. I'm not sure how long it's going to take. We're going to keep an eye on the oven. I'll keep everything recorded just the way it is, and we'll see what happens. We'll see if my fuse blow. We get hot enough to blow the fuse. If the fuse blows, shuts everything off, starts warming up. Make sure it doesn't keep going and catch fire. So here we go. I'm going to just pull the wire here. So the Adreno will no longer be in control of the SSR. We'll pretend that something went wrong. Now the oven is on and it's going to stay wide open, and we're going to have to keep an eye, and I'll have to stay in with this one and watch, so we don't end up burning the house down or anything. That wouldn't be good. We're going to be pulling some current. One thing about it being long enough, we'll find out if we're going to overheat anything. If the SSR is going to get too hot, we might fill an SSR. It's supposed to be rated for 6 amps, but based on the thermal, it might overheat. I mean, it does generate a little heat. It is warm. It's not cooking or anything, but we're pumping about almost 1.5 amps into it at a little over 24 volts. So anyway, we're going to be interesting to see what happens temperature wise. We can see that our board temperature is starting to come up. I'm going to go over and see. Let me spin around here and take a look at the computer. I'm curious what the oven temperature is doing. Well, she's not running up super quick, but it does look like it's creeping up. There's 47. Definitely warming her up. I think I'm going to sit over here, if it's okay with you guys, and watch the computer. Keep an eye on the temperature and see what we got going on. $65. So the oven says it's 65. So fuse shouldn't be too much longer. If that fuse is going to blow at 65, the top probably take a little longer than the side to get that temperature because it's farther away from the heating element. I don't know if it blows because the current will drop. I'm watching the current to the heater element. We're still got power to the heating element. The SSR is pretty warm. 69. Says it's 69 degrees. I would have thought that fuse would blow pretty soon. It's pretty well insulated in there, so it should be in the range of the temperature of the. Of course, the PCB is only up to 56 degrees. Fuse blew. Yeah, I directly hooked power and it's not. We've got a blown fuse. So the fuse did blow. I think the fuse blew. Took a little bit longer than I thought it would, but meter on continuity. Do we have continuity? No, that fuse is blown. It has absolutely blown, which is just what we wanted. So there you go. That'll take care of the safety issue. So we know the fuse will blow before we have a fire or anything. So that's good. So that's what we're going to do. I'm going to come up with a better way to mount this. I'm not sure exactly how I'm going to do it. I may well 3D print a little holder to hold it against the plate. I can use PETG, which is good for quite a bit more than 80 degrees C. So the fuse will blow long before that. That will probably help too, because if it's over the top of the fuse, trapping the heat, not letting it dissipate, probably make it blow a little quicker. But looks like it's going to work. Looks like that's going to solve our issue. We're not going to have any fires with the voltage calibrator, so that's a good thing. I don't want my house burning down from stuff. So that'll be a great way to, no matter what happens over here, if this thing goes crazy and starts overheating, fuse blows, can't possibly heat anymore. So that problem goes away. So hey, thanks for hanging in here with me. We'll keep coming up with all the different circuits and protections we need to get this thing done. I'm pretty well getting the controller board all worked out and figured out, about ready to get it laid out and ordered. That'll include solid state relays, SSRs, for both the heater element and also the screen power. I want to be able to turn the screen off when we don't need it, save the battery. So we'll get that, I'll pretty well get that worked up, and we'll do a video on that and get that board coming. And then we've got a lot of work still to do on the digital to analog board with the voltage reference and everything. Thanks for hanging in. Hit a like if you would, and hope to see you in my next video.